Hello, this is the fourth video of the third complex numbers series for OCR Pure Core AS Further Mathematics, and it covers dividing complex numbers which are given in the modulus argument form. You will remember from previous sections on complex numbers that we can write z as an x plus yi form, which is the Cartesian form. We consider then z1 equals x1 plus y1i and z2 equals x2 plus y2i, then z1 divided by z2 would be equal to x1 plus y1i divided by x2 plus y2i. We can calculate this by multiplying top and bottom, or numerator and denominator, by the complex conjugate of z2, which would be x2 minus y2i. We then use the fact that I squared equals minus 1 to calculate it. Here you can see GeoGebra, which is a dynamic way of showing the complex numbers division, where we have in this case z, which we can move around as we wish, and w. As you can see, the z divided by w, as shown by the purple number, changes as we change z and w, and you can see therefore that division, it's going to be a combination of enlargement, or if you like reduction, depending on the scale factor, and rotation. Moving on then to consider the division of complex numbers when they are given in modulus argument or polar form. If we write z1 as being r1 brackets cos theta 1 plus I sine theta 1 and z2 as being r2 brackets cos theta 2 plus I sine theta 2, we can see that z1 divided by z2 would be r1 cos theta 1 plus I sine theta 1 divided by r2 cos theta 2 plus I sine theta 2. If we expand this out and multiply numerator and denominator by cos theta 2 minus I sine theta 2, which is, if you like, apart from the R2 aspect, is the complex conjugate of Z2, then you can see that using the compound angle formula, which I've reminded you at the bottom of this slide, that Z1 over Z2 becomes R1 over R2 cos theta 1 minus theta 2 plus I sine theta 1 minus theta 2. You may wish to pause the video here and work this through carefully for yourselves. The results on the previous slide showed that when we are dividing complex numbers in polar form, we have that the modulus of z1 divided by z2 equals the modulus of z1 divided by the modulus of z2, and that the argument of z1 over z2 is the argument of z1 minus the argument of z2. And this result allows us to quickly divide complex numbers when they're given in modulus argument form. If we look at this example here, then, we can see that to find z1 over z2, we know that the modulus of z1 over z2 is just going to be, in this case, 6 divided by 4, or 3 over 2, and that the argument of z1 over z2 is going to be 5 pi by 6 minus pi by 4, using the information from z1 and z2 above. This would give us, of course, 13 over 12 pi. We have to check that the principal argument lies between minus pi and plus pi. Therefore, we would rewrite this as minus 11/12 of pi. We could, of course, check that minus 11 pi by 12 is the same as 13 pi by 12 using a diagram if we needed to. In the next session, 3.5, we will be covering modulus definitions for loci.